Good afternoon. Welcome to the session. You'll have to excuse me a little. I'm a little tired from jet lag, but let's get started. My name is Andrew Flavell, and I'm going to talk about how Nike secures its AWS infrastructure at scale. Before we get started, a little bit about me. Who am I? I've been at Nike for around 3.5, 4 years. I really joined Nike to drive a digital transformation from data center to cloud. And a large part of my role is working with very smart people, providing cloud platform and continuous delivery technologies to Nike's broader digital teams. For those of you who are wondering where my slightly strange accent comes from, I'm originally from a very small town in the middle of the North Island of New Zealand. What you should learn from this talk are really 3 key points. We use multiple layers of security, everything from securing our infrastructure with MFA tokens en route to how we secure our EC2 instances, how we use different communications models for different use cases, from developers to consumers, and how we manage secrets such as passwords, API keys, JSON web tokens at scale in the cloud. And we'll look at some really great work that we've done to solve problems here. But before we get into those topics, let's look at why Nike cares about digital at all. So at Nike, we're very passionate about sports and our consumers' potential. And Nike's mission is really about inspiration and innovation. For Nike Digital, this translates into delivering innovative products that serve individuals personally. And that could mean customized training or running programs, shoe or apparel recommendations, or a personal invite to one of the many live events that Nike executes around the globe annually. Our digital vision is very complementary, and it's delivering a portfolio of products to serve consumers personally. And AWS really enables us to do this. When we talk about the portfolio of digital products, it includes a broad array of digital properties, including Nike.com and our in-store experiences, as well as a constellation of mobile apps, including Nike Plus, Nike Plus Run Club, Nike Plus Training, and sneakers. So we have a concept in Nike that we call the sneakerhead, and I mentioned them briefly this morning. They're the people who are so passionate that they'll get out of bed at 5 a.m. on a Saturday morning to get access to our exclusive shoes. And we built the Sneakers app to make exclusive product access fairer and more accessible to our consumers. Unfortunately, even though I work at Nike, I never managed to get the really cool shoes. Like many people, I think, who are in this audience and are here at this conference, we're on a journey. In the past, we had owned data centers, large monolithic applications, very large and infrequent releases, and a trusted network perimeter security model. Today, we're in the cloud, we build microservices, we do serverless, we have continuous integration and continuous delivery. We use a lot of agile processes, and we have a zero trust security model. So the principles that I'm going to talk about here, particularly to do with security, and when building and deploying our services into the cloud, is that we only give users access to those resources that they really need access to. And that's what we call the principle of least privilege. There is no default trust for any entity inside our network. We use a zero trust model to compartmentalize different segments of our infrastructure. Managing security at scale also requires a ton of automation and self-service to ensure that all the code that is deployed is secure, without requiring overly burdensome human interaction. Similar to the principles that I just discussed, we also have a set of foundational elements when applying, building, and deploying our services to the cloud. So we always authenticate users to prove who they are. Then we use authorization to only give users access to the services that they really need access to. And we use encryption everywhere to protect our data over the wire and at rest. We're now going to dive into the layered approach we use to secure our AWS infrastructure. Why layers? Overall risk is reduced when there are layers of security because a compromise on one of the layers doesn't compromise the other layers. As I mentioned earlier, our approach to layered security includes everything from physical security to how we secure our EC2 instances. And we'll look at all of these in turn. First, let's look at physical security. We really care about this, as even the best protections in the cloud or other layers can be compromised or undermined given physical access to your infrastructure. All security begins with physical security, and this extends to AWS as well. All AWS facilities are physically secured too. Like most of you, we all have an ID badge that we use at work for authentication and authorization to get into the buildings that we need to access. And you only get access to those buildings that you really need to get into. Similarly, we use physical MFA tokens to secure access to the root of our AWS accounts. The MFA token is stored in a safe, secured with a combination, and the safe is in a security operations center. The entry to the SOC is secured, and very few people get access to that building. And the safe contents are regularly audited. We don't use software MFA on a phone, as it makes it much more complicated to manage access. The next layer in our stack relates to securing users using AWS's identity and access management. We have a corporate central directory service such as Active Directory or LDAP. And this is a source of truth for employee identity and authentication. We use an SSO provider to bridge between our directory services and AWS. And in AWS, IAM roles are mapped to the corporate directory services security groups. EC2 instance IAM roles clearly define what AWS API privileges are granted, and therefore supporting the principle of least privilege. We don't use IAM users, as they're much more complicated to manage, and self-service is very hard if you use them. From a network perspective, there are a number of things to consider. Only public endpoints should be externally routable within a VPC. An application should only be allowed to communicate with each other if they absolutely need to do so. This supports the principle of least privilege. We typically deploy our applications by domain, and each domain is encapsulated in a separate VPC. If a single VPC is ever compromised, it doesn't impact other VPCs, and that supports the principle of a zero trust model. We limit the protocols that we deploy on our EC2 instances in our VPCs. For example, we don't allow Telnet or FTP or SMTP. Network access control lists provide fine-grained control to individual subnets, acting as a firewall and a second line of defense to security groups. To further support the principle of least privilege, you can control access to AWS services using IAM policies, and you can control what actions are allowed, which resources allow the actions, and what the effect will be when the user requests access to the resources. In this really simple example here, it shows how IAM policies allow service 1 to access an S3 bucket and an SNS topic, while service 2 is blocked from accessing the SNS topic because it doesn't have the right policies. There are many vectors we take to secure our EC2 instances. We use security groups to control access. For example, a service should be allowed to communicate with its own data store, but another service shouldn't be allowed to communicate with the same data store. Security groups also limit attack vectors such that in the event of a compromise, your EC2 instance has limited other vectors. We use a security suite including antivirus, intrusion detection, intrusion prevention, and file integrity management to detect and stop compromises automatically as they happen. Wherever possible, there should be no human intervention required. We use patching to keep our instances up to date and to reduce available attack vectors. And apart from patching, we use immutable Amazon machine images so that the state of the application is well understood, which means they are easy to reason about, triage, debug, etc. We use a secure central configuration management to reduce risk by automating the creation of application AMIs in a repeatable, secure manner. By doing this, we have a known set of specific middleware and configuration processes baked into our AMIs. We're now going to look at how we use different communications models of routing, authentication, and authorization for different use cases. So why would you want to use different communications models for different cases? Each use case has its own needs and path through the network and must be considered and solved individually. There's no one-size-fits-all solution. We really need a different approach if you're a developer connecting to EC2, a business user connecting to the services, such as a customer support representative helping a user with an order, an end user connecting to the services for their application, for example, running or NTC, server-to-server calls connecting two services in different VPCs, between services within a single VPC, and finally, service to data store inside a VPC. The important thing to keep in mind when we look through the examples in more depth are the fundamentals mentioned earlier, specifically authentication, authorization, and encryption. So here we have a consumer accessing an application running on an EC2 instance in one of our VPCs. She connects via api.nike.com through our API gateway to domain 1, and then an edge router, and then to the services running on EC2. So we use application layer authentication, OAuth, OpenID Connect, SAML, basic auth, and an application authorization. And then we use JSON web tokens to dictate the allowable claims. Again, this is supporting the principle of least privilege because we only give you access to those services that you truly need access to. And finally, we make sure that everything's encrypted with TLS. Here we have a microservice to microservice communication across the public internet. So we use cross-domain service discovery using DNS. And authentication and authorization is provided by OAuth and JSON web tokens respectively. And in this case, we always encrypt the traffic using TLS. Here we have microservice to microservice communication within a VPC. Here, service 1 has permission to access service 2, but service 3 does not. We use authentication and authorization via security groups in this case. And this may or may not like encryption. So it's very hard to manage thousands of security certificates at scale. And since the risk of compromise in a single VPC is very low, for data that we deem to be non-sensitive, we don't always encrypt it. Here we have a developer that needs to connect to an EC2 instance within a VPC. So the common options for doing this are either using a proxy with a NAT or a Bastion host. In this case, we connect from the corporate network via a direct connect to an AWS VPC containing a proxy and a NAT with an elastic IP. We use SSH like this as it only allows employees from inside the company firewall who are authorized to use our proxy server to even attempt to do the SSH to the instances. This greatly reduces the attack surface because you can't get to these endpoints from the public internet. Employees must still have the right key to actually successfully SSH in. Private endpoints, SSH data stores, should not be exposed to the public internet. And this supports our principle of least privilege. Finally, in this set of examples, we have a microservice that needs to access its own data store. We typically use a data store protocol. For example, it could be MySQL or Cassandra. And typically, all communications are encrypted and the data is encrypted at rest. Authentication and authorization uses passwords for the application layer and security groups at the network layer. This ensures that only authorized applications can even attempt to connect to the DB. The data store username and password are required for authentication and authorization. This is a nice segue into the next discussion on how we manage and store passwords at scale. So let's look at managing secrets using our secrets and dynamic property store called Cerberus. So Cerberus is the mythical guard dog of the Greek underworld. At Nike, Cerberus is the guard dog of our secrets. Why did we build Cerberus? We wanted to use existing solutions, but didn't find anything that met our needs. There wasn't really anything that was secure, end-to-end, was easy to use, cloud native, and so we built Cerberus. So the Cerberus composed REST API wraps key components of the Cerberus secret service. We use HashiCorp Vault as the central, and this is central to Cerberus, and I'll talk about that a little bit more in a minute. We have a Cerberus management service, which is really a microservice built by our teams to handle authorization and metadata. We have the Cerberus management dashboard, which is a simple single-page app that's stored in S3. A user can interact with Cerberus either via the management console or the command line, and authorization is done via the corporate directory services. Cloud applications in EC2 or Lambda and any AWS account authenticate using IAM roles, and we have multiple clients available today. So I'm not sure how many of you are familiar with Vault, but Vault is a tool that's both open source and commercial, and it's for managing secrets, and it secures, stores, and tightly controls access to those tokens. Passwords, certificates, API keys, etc. Amongst other things, Vault handles leasing, key revocation, key rolling, and auditing. So why didn't we just use Vault out of the box? Well, there are a number of things that Vault doesn't do well, including IAM role-based authentication, user authentication via an SSO provider, cloud-native operations and infrastructure. So Vault is not particularly fault indifferent and requires a non-trivial configuration to get it up and running. So we built Cerberus to add all of these features, so it has automated provisioning and fault tolerance, and a UI for managing access control and secrets. At Nike, we use Cerberus to manage secrets, such as passwords, API keys, JSON web tokens, and also as a general purpose runtime config store. At Nike, we've done a lot of work to adopt what we call an inner sourcing model. And so many different teams across the Nike digital organization have contributed clients used to communicate with Cerberus service. This now means that we have clients for HTTPS, Java, Netflix's Nike's framework, Ruby, Python, Node.js, and Jenkins. And if you really want to, you can still just use the dashboard to access Cerberus. For those of you who have an interest, I'm pleased to say that we open source Cerberus on GitHub, and I'd like to invite you all to download it and check it out. Speaking of open source, we've recently released a number of technologies that we've developed at Nike on GitHub. These include FastBreak, a simple Java 8 native circuit breaker supporting async futures, blocking, and callback manual modes. Wingtips, a distributed tracing solution for Java based on Google Dapper paper. Cerberus, which I've already talked about. Willow, which is a powerful yet lightweight logging library written in Swift for iOS development. Backstopper is a framework-agnostic API error handling and optionally model validation solution for Java 7 and up. And Elevate is a JSON parsing framework that leverages Swift to make parsing simple, reliable, and composable. So we're getting close to the end of the talk. So again, what I hope you took away from this talk is that we use multiple layers of security from physical to EC2 instances to reduce risk if a single layer is ever compromised. We use different communication models for different use cases, not one size fits all. And we developed Cerberus to manage secrets such as passwords, API keys, JSON web tokens at scale in the cloud, and it's now available on GitHub. In closing, I'd like to digress a little bit and talk about Nike. I'm not sure how many of you are familiar with Nike's maxims, but you can think of those as the company's core philosophy, used to influence, inspire, and challenge employees on a daily basis. I think it's telling that Nike's #1 maxim is all about innovation. Nike sees innovation as one of the core organizational competencies. In Nike Digital, we're driving that innovation for our consumers, and AWS is central to our success. Thanks very much.